let n be a fixed positive integer. Define a relation R in capital Z, that is integer, as follows: for all a comma b belongs to capital Z and a has relation with b if and only if a minus b is divisible by small n. Show that R is an equivalence relation. So relation is equivalent relation if and only if it is reflexive, symmetric and transitive. Any relation is equivalence relation if and only if it is reflexive, symmetric and transitive. So here we have given that A is related to B if and only if A minus B is divisible by N. So here we can see for reflexive, A is related to A. All relations are identical relations. So A is related to A. It means that A minus B, instead of A minus B we can write A minus A, that is 0. So 0 is divisible by any number. So it is divisible by n. So it is a reflexive relation. Hence given relation is reflexive relation because a minus a is equals to 0. So 0 is divisible by any number. So it is divisible by n. So given relation is reflexive. For symmetric, a is related to b, then we have to show that b is related to a or not. If b is related to a, then it is symmetric. So we can see a minus b is divisible by n. Then take minus sign from this bracket, we will get b minus a. So it is also a divisible by n. So we can write b minus a without negative sign. We can write b minus a is divisible by n. So a minus b is divisible by n. So we have taken minus sign from this bracket. We can write minus of b minus a. So it is also divisible by n. So without negative sign we can write. So for a divisibility, negative sign doesn't matter, or it will not help for a divisibility. Okay. So only the number is important for us. So b minus a is divisible by n. So from here a is related to b if and only if a minus b is divisible by n. So here b minus a is divisible by n. It means that b is related to a here. So we can see a is related to b as well and b is also related to a. Hence given relation is symmetric relation. Now let's see transitive relation. In a transitive relation, A is related to B and B is related to C. Then we have to show A is also related to C. So we can see A minus B is divisible by N and B minus C, that is B related to C, that is B minus C is divisible by N. If we add these two, what we will get? A minus B plus B minus C. So these two terms, if we add these two terms, these terms are also divisible by n. If we say 4 and 8 both are divisible by 2, if we add them and if we divide by the same number, then summation of those number also divisible by 2. So it means that a minus b plus b minus c is also divisible by n. So we can see minus b plus b get cancelled out. So we can write A minus C is divisible by N. So we can see we have to show that A is related to C here. So we can see A is related to B here. Hence the given relation is transitive as well. So we have shown given relation is reflexive as well, it is a symmetric, and it is transitive as well. Hence the given relation is an equivalence relation.